And it just does it, right? And then you get to go in and you do the fun things where, if we move that out of the way, where we actually do things that are capacitor specific, right? So we talked about it for just a moment, but if we jump over into the components into our context, right? Our haptics, right? So you'll see we imported our haptics from the Haptics plugin, and we just say, do a little impact, right? Which is just that little bit of vibration there. And we could pick a style. I went with medium. That felt like pretty good size. There's a couple others, right, where there's light, medium, and heavy. Heavy felt like, your phone is getting in a fight. So I just a little bit too much. So I went with medium, and that felt really good. And this is great, right? Because this haptic engine will also work on web, which is great. So that if you have a mobile phone and it does support haptics on web, you'll also get that haptic feedback on web, which is great. You could gate this so that if you only wanted to run it on certain places, you could, right? That Capacitor has a couple of helper functions for that. You can wrap this. But this is great, right? We can leave this in and it doesn't impact our web at all, right? We've been running this in the web browser. And that's great, right? So it took us 15 to 20 minutes, we'll say, right, to actually add Capacitor, run all the NPM installs, do all of that different parts of it, add the iOS and Android projects. And at this point, we're ready to ship this to the iOS and Android stores, right? So all of that is really great. And that's really what it comes down to kind of shipping this as a Capacitor application. Yeah. Any questions, Logan, before we we still haven't talked about how we're doing the ChatGPT part, which I think could be kind of fun to dive into if we got some time, but
no, I mean, let's do it. Let's jump into the ChatGPT stuff. So I would love to learn about the ChatGPT items and how we're actually like how you're integrating with it and how like it's connecting to your application.
Yeah. So let's talk about how it talks with ChatGPT. So everything up to this point has been inside of our project root. This is all of our web application. We talked about, adding this to Capacitor and how that all works. So if we jump into the other part of this workspace, so this is our Supabase functions. This is our edge function. We have one function that is chat, and it has an index file. So the way the chat function works here, we'll move some of this interface out of the way. So the way the chat function works is this method will get bundled up by Supabase and it will get thrown into the cloud and it will run on their edge servers anytime you try to connect to it. So we're using this serve function, which is from Dino, right? And this will serve this edge function. This is what will make it accessible over HTTPS. And we're just going to kind of dive through from there. We're also relying on LangChain. We can ignore all the red squigglies. That's just VS Code having mental issues. All of this does work and it is all installed. So we have this method. So anytime we make an HTTP request to our chat endpoint, it's going to execute this with all of our request details. If you're serving this from web, if you're dealing with a browser, which we are both in Capacitor and on our web, right? Both of those are running in a web browser. You have cores to deal with. And so that includes options requests where you have to reply with specific cores headers, right? You can look at this. This is super basic. Our cores headers are just setting our origin and headers that are allowed to be sent to this. And we're just taking the most lenient approach possible and saying, yes, anyone can talk to this endpoint. You could restrict this to a certain, domain or set of domains if that's what you wanted to do. But for our case, we're okay with anyone invoking this method. Once we've done that, we are pulling all of our parameters that we've sent up from our JSON. So you'll remember we sent up our user input, the message ID of the AI message to be created, and the chat with which this is all corresponding. If any of those are missing, we're just going to quickly throw a bad request and be like, hey, you're missing something. Send us all the right data. And then we're going to create two different Supabase clients, right? We have our Supabase client, and we also have our Supabase admin client. The reason for these two different types, this one will be tied to the current user, right? So whomever is actually actively logged in is going to utilize this, right? And that way, all of the row level security policies we added at the beginning are put into effect. The admin client, however, uses the service role as part of its access, and so it can bypass all of the row level security. And we're okay to do this on, again, we're on the server side, right? We control all of the data that's going on right now, so we can safely use this to bypass specific RLS policies, and we'll talk about those at the end of which ones we're bypassing and why. So we're going to grab our user Supabase instance. We're going to make sure that there is an actual user, and we don't want any non-logged in user to be, trying to talk to our function and using our API keys. That we want to be in control of that. So if there's no user, we throw an unauthorized error back to the user. The next check we're going to do is we're going to, again, with our user Supabase client, we're going to try to grab the chat. And we do this with our user one because we wrote that RLS rule a while ago about how only users who are in the chat can actually access that data. So if the user is not related to this chat in any way, this will come back empty and it will throw this chat error and say, hey, there was no chats. There's nothing there. Whereas if it is the actual user, the RLS policy will enable the user to select that, and we will get the chat data back from Supabase. If we don't, we just throw 404 not found. The chat they're looking for doesn't exist. Next, we're going to grab our model name. So we had that selection, right, of ChatGPT 3.5 or 4. We store that on our chat as the chat model value here. And so we're going to select that in case, in the off chance that for some reason chat model is invalid because of one reason or another, we're going to fall back and use 3.5. And then we do have code here so that this will use event streaming, which is what we've been using. If we don't support streaming, this function will also do the chunk, right? It will wait for the entire response back from ChatGPT and then send one single response back to the client. Then we get into the fun part, right? Now we get to talk about ChatGPT and how that works. So one of the more complex parts of this is memory. How does ChatGPT remember what you're doing? And we're implementing that in 3 distinct ways. The first one is we want, for immediate context, we want it to know what the most recent messages were. This is how it knows, what was the very last thing I asked, so that it understands what is the back and forth going on right now. Then we also want it to know what is the summary of the conversation, right? What has been the flow of this conversation over time? How has that gone? This gives our GPT instance this long-term context. And then lastly, we have a vector store for in-depth knowledge, right? So if we want it to remember specific details like my name, right? A summary probably isn't going to contain that, maybe for 1 or 2 messages it will, but after a while, the summary will, enough conversation has happened to where it will condense that and it'll just say, the chat, the AI and human introduce themselves or something like that. So the vector store is for actually storing very specific in-depth knowledge about the entirety of the conversation. So those are the 3 different memories we're going to configure. So the first one for most recent context is we grab our chat messages and we're just going to grab a certain number, right? In this case, we're doing 2. That's just kind of what I played with. But you could do more, you could do less. You need to be careful with how much you do because, if we kind of take a peek back here at our previous message, right? If we do our 2 most recent messages, it might give you thank you and this whole giant block of text. All right. That is a lot to send back to ChatGPT as context. And if you're also sending, 3, 4, 5, we hit 6, there's another giant wall of text, right? So we kind of want to be careful about how much immediate context we're providing so that we're not spending all of our tokens, right? You can only type in so much to the prompts. We don't want to spend all of that on our history. So we're just going to do a little bit. We're just doing 2. So that seemed to work for me as that very immediate context. We also want to make sure that we're not grabbing like the AI's message or the message that we are currently writing because we already have that information. We'll throw an error in case, something goes wrong there. That's an internal server error. There's nothing the user can do about that. The buffer memory is how LangChain operates to manage recent memory like this. So we're just creating, assigning this to a recent messages key. We have our chat history. Again, chat message history is provided by LangChain, and you just provide the messages, and it has these helper AI messages or human messages. And those are just there to help LangChain better understand the context around each individual message. Once we have those, we're going to jump to our vector store. So we're going to kind of skip over our memory summary or our chat summary for the moment. Our vector store, so this is our in-depth information. So Supabase vector store, again, this is provided by LangChain and Supabase together. We're using OpenAI embeddings, and if you haven't gotten into this, we're not going to dive into what embeddings are because it's complex math. I don't really get it. I just know they exist.
You just need to know that it's there.
Yes, you just need to know that it's there and it's going to do its thing. That's the tool we're using to turn all of our text into numbers that mean something to the AI. We're going to use our client, and you'll notice we're using our Supabase admin client here, right? We're not using the user version, we're using the admin version of this because we're accessing this chat memory table, which we haven't talked about this yet. We probably won't get into this other than this is where we're storing all of our vectors, and the RLS policies restrict anybody. So nobody can access this. And that's why we need to use the admin client for that. And then we have a database query for match memory. So this is the Supabase function for how it reads the vectors. Again, we won't go into that. If you're interested, the Supabase docs describe that really well. So we'll link to those. And then you could also, again, take a look at this GitHub to kind of see exactly how we've tweaked that and implemented it for our application. Once we set up our vector store, right, where all of the vector information comes from and gets saved to, we create this vector store retriever memory. This is, again, another LangChain class that is how does it operate as memory for the bot and for the AI. We tell it how many data points we want to return. So you can, again, tweak this. I liked 5 points. I don't have a big sample size as to the impact this might have in terms of cost and message size, but it was working well enough for me, so I kept it at that. And then our memory key. And then we create our combined memory with these two. And again, you'll notice we don't have our summary yet, and that's because we're doing something a little different with that. But we have our buffer memory, that's our immediate context and our in-depth context. And then we create our prompt. So this is our prompt, super basic, nothing too crazy going on here. The main parts of this is our summary of the conversation. So you'll see we actually save our memory summary on our chat object. This is part of our chat table. When we initially created the chat table, there was no such thing. If we open this up and go back over to Supabase, you'll see we actually have a migration here for chat memory and how that works. And you'll see we added a column for memory summary to our chat table. So that's where we're storing that information. So we have our memory summary, and then we also provide it with relevant pieces of previous conversation. And that's our vector memory. You'll see vector memory is a key here that lines up with the memory key. Our recent messages, which again, recent messages has a key that lines up with our buffer memory key. Here is our new user input, and our input is our prompt input template variable. And then we expect the AI to respond. We create a prompt template off of that. We say, here's the variables that we're going to go into that. Here's the template. We'll just talk about the streaming response. We won't worry about, the single response objects variation. A lot of this is copy pasted from LangChain docs. So there's not a lot you need to really know to get to use this. All this is doing is setting up that streaming behavior so that you are actually getting that real-time stream back to your client. We're going to create a chat OpenAI. So there's OpenAI and there's chat OpenAI. So depending on the different models you're using from OpenAI, we want to use the ChatGPT variation. So we're using chat OpenAI. Our model name, which we assigned earlier on in this application, whether we're using 3.5 or 4. We talk about it, are we using streaming or not? And then we have our callback manager. So these are really the 3 functions you're going to use, and they get called anytime something happens. So whenever the AI responds with a piece of text, right? This is our new token, right? If you're familiar with OpenAI, everything is grouped in tokens. It doesn't necessarily mean word, it doesn't necessarily mean letter. It's just a variable amount of data. So anytime there is new data, we are writing this back to the stream with all of the data. We're also keeping track of this we have this full text variable so that we know what the final version is at the very end. In case there are any errors, right, we're just aborting the stream. That will abort on the client, and the client will handle that. And then lastly, we have handle LLM end. So when it's finally done with its response, we're going to go ahead and close the writer, which will tell the UI that it's done. And then we're going to use our Supabase admin to write to the chat message collection, and we're going to insert that full text created by AI. And you'll notice we're using the admin client here again, and that's because we're bypassing rules, right? There was a specific RLS rule we added where you could only write to that if you're a human, right? So if we use normal Supabase, this will not work because it will violate that human requirement that you have to be to use. So that's why we're using our admin to bypass that and create the AI message here on our server. And then lastly, we have our summary. So we kind of glossed over this at the beginning of where that summary came from. We have a method here that actually is keeping a running summary of the conversation as it's happening. So we have this method, and it takes in the existing summary, the user input, and the output from the AI. And when we jump to that function, you'll see we're actually prompting back to ChatGPT again. And we have this template. Again, you can kind of come in and read this in the GitHub. But the TLDR is take the current summary. Here's the new lines of conversation. And here is the new summary that you should output. And so we give it that example so it knows how to respond. And then we actually give it the data. So the current summary, which is our input, which is our existing summary from our database. We pass in the new lines of conversation, the new human message, how the AI responded, and then we expect it to give us a summary. And then we're just going to pass that to ChatGPT. We're just using 3.5. We don't need version 4 for this. We want something quick and cheap. And then when we call that, we're not doing any data streaming here, nothing crazy and complex. We just wait for the response, and then we send the text back. When we get that text back, that's our new summary. And so we're just going to go update our chat. And we're going to go ahead and update that memory summary. And again, I'm going to point back to our RLS rules, right? We explicitly did not enable updating for the users because we don't want them to come in and mess with this memory summary. So we're using our admin so that we can bypass that rule so that the server can update our memory summary safely. And with that, that's everything that's going on here, right? So if you scroll down a little bit more, this is the exact same behaviors. This is just for the bulk response, right? Where it gathers the entire message and sends the response back in one go. And then if anything goes wrong, we just throw a generic 500 error with the message being like, I don't know, something blew up somewhere we weren't prepared for. and that's it, right? So it feels complex to kind of wrap your head around it, but then if you break it down piece by piece, there's really not a lot going on, right?
Yeah.
We validate our input, we configure our memory. How does the bot remember things? And then we ask it a response and we send it back to the client.
Well, there you go. That's awesome. That's pretty straightforward.
It's really great, honestly.
Yeah.
This has been a really fun project to build. And here's the great part about this, right? So this is all open source. If you want to just build and run this yourself, you absolutely can. Here's all you got to do, right? You're going to come back over to this. You're going to clone this repo. You go over to Supabase, right? You go to Supabase, spin up a free project, right? This is all running off of a free project. So go spin up one yourself, call it whatever you want. Grab the information you need and create this env.local file, or take the env.prod. This is mine, right? You can try to connect to it and hit the auth endpoint a million times if you want. But come in and drop in your configuration. What is your Supabase URL? What is your anonymous key? Okay. That's all you got to do to connect to your own Supabase. The migrations are already here. So you can use Supabase to link your database and then push all of these migrations up to yours. Or you could just open them, copy paste into your remote instance, right? All of these will work. That will bring your database to where it needs to be. And then the last thing you need to do is create a .env file here in your Supabase folder, right? This is for our functions. And by default, all of the functions they already have access to your Supabase instance because Supabase manages all of that. So you'll come in, and you'll create your OpenAI key, and you'll drop in yours. This is mine. It's going to be dead by the time you can try to use it, but it'll be gone. Don't worry. But you create this .env local file, right? And that's literally all you need to do. And you can spin this up and run it yourself, and talk to ChatGPT day in and day out as much as you want. That's the steps to clone this and build it yourself. So it's set up so that it can be super easy to do, really, really straightforward, so that anybody can take this for a spin and play with it and do what you want with it.
That's awesome, Dallas. Thank you so much for showing us this. Where else can we find your work? Where can we go? Where can we find you, and what you're currently working on?
Yeah, so I don't do a lot of building these days, so this was actually pretty fun for me. So that we kind of mentioned at the beginning, so I'm the product manager for Capacitor. So my job is just to try to understand how people use Capacitor and try to make sure that it does all the things that people want and expect it to do. So if you have any questions, I hang out in Discord a lot. So we have our Ionic Discord, which will be linked somewhere, right? Up there or over there. I don't know where things get linked. Yeah, come hang out in Discord, and you can just feel free to ping me. I hang out in all the Capacitor channels and try to answer questions whenever I'm over there and help people out. I like to ask questions for feedback over there. So if you're wanting in, you want to share some feedback, that's the place to do it. Yeah, come hang out with me in Discord, and we'll chat. You could try to talk to me on Twitter or X or whatever. I do stalk over there a little bit, but Discord's way more fun these days.
Yeah, Discord is where it's at.
It really is. So yeah, come hang out with me over on Discord, and I'm happy to help with any questions, or if you have any questions about this project specifically, right? Hit me up. I'm happy to talk about any of the tech used in it. If you want to just talk philosophy, or if you have specific questions, let me know. I'm always happy to sit down and chat with you.
That's awesome. Thank you so much, Dallas. And again, my name is Logan Braid, developer advocate here at Ionic. If you like what you see, please like and subscribe to the YouTube channel. And we hope to see you guys soon. Thank you so much. We'll see you later.
Take care.